Okay, welcome to the video on model problem number 4. This problem says a sample contains 1.204 times 10 to the 23 NH3 molecules. How much does it weigh in kilograms? So in this case, I am given the number of molecules and I'm asked to find the mass. But I'm specifically asked to find the mass in kilograms. So in the end, I'm going to have to do an additional conversion. Well, my plan is simple. I am going to start from here, number of molecules, go to the moles using the 1 mole is equal to 6.02 times 10 to the 23. Then once I have the moles, I'm going to go from moles to my mass using moles equals mass over molar mass. All right, so let's go ahead and get started in looking at our work here. So first thing is to convert from moles to number of number of molecules to moles. And I showed this in the last video, so I won't spend too much time going over this, but I'm going to start with I'm going to use dimensional analysis to convert from my number of molecules to moles. I take my given 1.204 times 10 to the 24 molecules, my given over 1. And I put it over 1 just to make it to a fraction. Notice this is just 1. It's not 1 mole. You just putting it over 1. No unit should be here in this first fraction, typically. Now for my second fraction, my conversion factor, I'm going to get that from the relationship that 1 mole is equivalent to 6.02 times 10 to the 23 molecules. Now since I want to cancel out molecules, so I'm starting with molecules, I want to cancel that out. The part of this equation that has molecules must be opposite. So that means it has to go in the denominator. My given fraction, it's the number of molecules, that unit's in the numerator, and the second fraction has to be the denominator. So I've plopped that here. Now what I have left is 1 mole, that goes here. So I go ahead and I plug that into my calculator, because when I do that I multiply straight across, so 1.204 times 10 to the 24 divided by 6.02 times 10 to the 23. And that's going to give me 2. So just to show you what that looks like when you plug that in, remember it's best to use, if you're using a calculator, use that e function. So 1.204 second e, then you just put the power, 24, divided by 6.02 second e to the 23. Now I don't think you need to put parentheses around the numerator and denominator. I like to do it just because depending on the calculator you use, sometimes you have to, sometimes you don't. So I typically just do it, although I don't think you need to with this type of calculator. All right, so then we have 2 moles. So that's the first step, converting from molecules to moles. Now the next step. We want to convert from moles to mass. So to do that, we're going to use moles equal to mass over molar mass. My moles, I've solved for that already. It's 2. So that 2 gets plugged in there. And my molar mass, I solve using the periodic table. So that goes here. And that gives me this equation, 2 equals mass over 17.04. So to solve for my mass, now I'm going to use cross multiplication since I have a fraction next to an equal sign. And that gives me that mass is equal to 2 times 17.04, which is 34.08. And the unit here is grams. Now, my unit right now is in grams, but remember I need to convert it to my final answer into kilograms by just dividing this by 1,000. So I take the 34.08 divided by 1,000, and that gives me 0.0340 kilograms. Now the last thing I'm going to do is get my correct number of sig figs. If you go back to the problem, you will see that in the problem there are 4 sig figs. So technically I could have 4 sig figs. However, the Avogadro's number value that I used only has 3 significant figures. This actually is a longer number than that. This is not as precise as it could be. So I have to cut mine off at 3 sig figs because of my Avogadro's number. So I'm going to go ahead and just cut that off at 3 sig figs. So 1, 2, 3. These are my 3 sig figs, and I would just round that up since the number to the right of the cutoff is greater than 4. And so this is my final answer. The mass is 0.0341 kilograms. Okay. Now what I'm going to do is show you what it looks like with dimensional analysis. So for dimensional analysis, you're going to do the same sort of thing, except for instead of plugging into equations, you're going to do your given over 1, then you're multiplied by your first conversion factor, and then your second conversion factor, and then solve for your find. Now you'll notice that in your conversion factors, the first one, 1 mole should be on top, and then the second one, the 1 mole will be on the bottom. That's the typical setup. All right, and so that's what we have here. We take our given, put it over 1 just to make it into a fraction. And then our conversion factor to go from molecules to moles is 1 mole is equal to 6.02 times 10 to the 23 molecules. That 1 mole goes on top, molecules go on the bottom. Then to go from moles to mass, we're going to use our molar mass, and then the mass will go on the top. The 17.04 grams goes on the top, and the moles goes on the bottom. And we can see here that our units do cancel out. So our molecules cancel out since they're opposite, and our moles cancel out, and so we're left with units of grams. And our math looks like this. We multiply straight across, so 1.204 times 10 to the 24 times 1 times 17.04. So that's, oops, there's a mistake here. It should be 17.04. Okay, so those numbers multiply on the top there. And then in the bottom here, we divide it by 6.02 times 10 to the 23. So once we do that, we'll have our value, our mass in grams. Then we can divide that by 1,000 to get it into kilograms. And of course, we're using 3 sig figs since we've only had 3 sig figs for our Avogadro's number. Okay, so that is dimensional analysis. The other thing we can do, we can actually do all of this in one step, and I just want to quickly show you this, but you don't have to do it. So we can convert from our number of molecules to moles, and then from moles to grams. And then we can convert our grams into kilograms by studying the 1 kilogram is equal to 1,000 grams as a conversion factor as well. And so you will see when you do that, you set it up properly so that the units that you don't want cancel. If we have grams here, we want to get rid of grams. The 1,000 grams goes on the bottom, and the 1 kilogram goes on the top. All right, I just want to show you that because you may also see that sometimes people do it this way. All right, that is it for this video. So we've got our problem 4. The last problem is problem 5.